Okay, last podcast. Let's make this one the best one yet. Unlikely, but that's okay. So in this example, now this is one of the more difficult examples that you'll deal with. It says find the values of the coefficients a and b. All right, it's good to know that a and b are coefficients, meaning that they are variables representing numbers. The only true variables in this whole problem are x. X is the only true variable. So a and b, you have to remember, are representing numbers. And I kind of started to set this up yesterday a little bit. What we have in this problem is we have two polynomials that are being added together. So what we can do is we can combine like terms and then that is set equal to another polynomial. Well, our first step is to combine all of the like terms. And I see right here I have an x cubed term and then another x cubed term. Now the key, we mentioned this yesterday too, when we combine like terms, what we do is we end up adding the coefficients. The coefficient of this first term is 1. The coefficient of this other term is a. So if we were going to combine them into like terms, we will end up adding their coefficients, 1 plus a. Again, we don't know what a is, but we know it represents a number, and that will be the coefficient for our x cubed term in simplified form. The next term we see here, and there's only one of these, is the x squared term, negative 4x squared. There's only one, so we can leave it how it is, negative 4x squared. Oops, excuse me. There we go. All right, the next term we have is our x's. We have a negative 2x here and a positive 2x here. So now when we combine these, when we add the coefficients, negative 2x plus 2x, what do we end up getting? 0x. That's right. Very good. I'm assuming somebody got that. Come on. All right, so when we add these together, I'll just add a 0x to this part of the equation. Again, you don't have to put this in, but I am for effect right now. And then the last terms we have to combine are the constants. Remember, the constants are the terms without any variables attached to them. So again, if I'm going to add this constant, I'm going to add the terms combining together. So we have a positive 1 and a negative b. That will be my constant term. Good. And it's good to know, again, that this is all set equal to the other side. And what I'm going to do is I'm going to color code the other side similar to how we have it coded. Our x cubed term is black, so I'm going to write the x cubed term as black on the other side. And then the x squared term is blue, so minus 4x squared. All right. And then our, again, looking at the other side, it does not have an x term, so I will do the exact same thing as I had on the other side, plus 0x. That should be plus 0x, not plus qx, but you'll deal with it. All right, and then our last term is the constant plus a 5 here. All right. So now, if this polynomial is equal to our other polynomial, well, the only way that that's possibly true is that if all of the like terms are identical, which means these x cubed terms have to be the same. In order for the x cubed terms to be the same, their coefficients must be the same, which means 1 plus a must equal 3. From this, we can find that quite easily by subtracting 1 that a is going to be equal to 2. So there, we're halfway home. Our x squared terms, they already match up. Negative 4x equals negative 4x. That's good. It should. Our x terms also already match up. 0x equals 0x. And now, again, in order for this to be true, we need our constant terms to match up as well. So we need 1 minus b to be equal to the other constant, which is 5. And again, if we do a little solving here, maybe you subtract 1 and then divide by negative 1, you find that b is going to be equal to negative 4, yeah. Second guess myself there for a second. All right. So if you need help with this, go back through it, but that's how we add and subtract coefficients of like terms to find out what the variables representing those coefficients are.